Today we are looking at student handout 4, which is in unit 3 of decimal operations. Okay, so in the fill in the blank, a number might not have an equal number of pieces in each group. So please write in the word equal right there. After that, we are going to divide the number of flowers into 5 groups. So if we notice, we have a total of 1, 2 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 flowers. 2 times 11 would be this array. That means it's 22 total flowers. So I know that if I divide 22 by 5, I'm going to have 1, 2, 3, 4, 5 equal groups with 4 flowers in each group. How do I know that? Well, I could certainly just sit here and play with the flowers and break them into groups. Or if I know my 5s tables, I know that 5 times 4 is 20. So 5 times 4, that means 5 groups with 4 flowers in each group. And then of course I'm going to have 2 left over because there was a total of 22 flowers. So below here where it says what happens, how can we represent the flowers that are not in that group? Well, these leftovers we would call remainders, right? You should try to say that at the dinner table. Please package up these remainders, the remainder of the food on the table, right? Package up the leftovers, put them in the fridge for next time, all right? So with these flowers, we have 2 remainders. Here you could write something like this. Not all of the flowers can be equally divided into 5 groups. There are some leftovers, which are called remainders. We can also show that part of the flower will be split into groups. Now, you definitely don't need to write it like that. You could write, what happens? Well, we can divide them into 5 groups, and then there's 2 leftovers. And leftovers are called remainders. Anything like that would be totally fine. Below here in the dividing decimals box, it says when the dividend is a decimal, you can follow the rules for dividing whole numbers. However, remember to keep your place values organized and bring the decimal straight up into the quotient. So we're saying these words without the reminder here of what we're talking about. So let's just review that really quick. When you have a divisor, the divisor is on the outside. Remember, your visor is needed for outside in the sun. Your dividend is inside the bracket, and then the quotient sits on top. The quotient is the answer to a division problem. So what this is saying, when the dividend is a decimal, if there is a decimal sitting somewhere inside of that dividend, you can follow the rules for dividing whole numbers. So that means there's no decimal outside in the divisor. This is a whole number. So we are literally just dividing by a whole number, right? Like the number 2 or the number 3, or this case, the number 5. All you're going to do is let that decimal float up and sit right up on top of the quotient, right above the line, wherever it lands. And you're not going to worry about where it lands as long as it's just going straight up. That's because this divisor is a whole number. Now later on we'll talk about how to divide with a decimal. If there was a decimal out here, you might have to do some more scooping and remember that scooping song. But for now, if there's only a decimal in the dividend, you just let it float straight up and sit on top of the bracket or the quotient bar, okay? So right here it says, however, remember to keep your place values organized and bring the decimal straight up into the quotient. So please write the word quotient in that fill in the blank. And let's look at how this works. So we're now going to practice dividing the values below, and we're going to use the grid to keep our place values organized. Okay, so for number 1, we have 53.2 divided by 14. Okay, so again, the 53.2 is going to go inside. You could put it right inside of its own box for this problem. There's enough room, or you could just put it right on the line. But 53.2 divided by 14, okay? So here we have the 14 again is on the outside in the divisor. We're wondering first, how many times 14 fits into 53? If you want to take care of this decimal before you even do that, I gave it its own box for this one because I wanted to show you that it literally just floats straight up and sits there. Okay, so let it float straight up and sit there, and then you can just ignore it and divide as usual. So in order to do 14 into 53, we need to know that 14 fits into 53 3 even times. 14 times 3 is 42. Then we subtract. Remember, our long division does McDonald's sell cheeseburgers rare? For divide, multiply, subtract, check, bring down, and repeat. Okay, so we are subtracting. 3 minus 2 is 1. 5 minus 4 is 1. So we have an 11 remainder. Bring down the 2. Notice it had to kind of jump over a little bit because I used the whole box. Sorry about that. So 14 into 112 goes in 8 even times because 14 times 8 is 112. And 112 minus 112 is a happy 0. No remainder, okay? Taking a look at number 2, we are following the same process. And I'm sorry, for number 1, the answer was 3.8, of course, which you saw here. But so we have 378 in the dividend, 30 is in the divisor. Okay, so reminder, any whole number can be made into a decimal by putting a decimal and an infinite number of zeros on the end if needed, which I believe is what's going to happen here. So we have the 30 on the outside. How many times does 30 fit into 37? Fits in 1 time. So here's the 1 above the 7. Note your place value. 30 times 1 is 30. 7 minus 0 is 7. Bring down the 8. 30 fits into 78 2 times because 30 times 2 is 60. 8 minus 0 is 8. 7 minus 6 is 1. Bring down the 0. How many times does 30 fit into 180? Well, I know 3 fits into 18 6 times. So 30 fits into 180 6 times. And 30 times 6 is 180, and 180 minus 180 is a happy 0. Now what happened here is that we had an 18, and we were like, 30 doesn't fit into 18, what do I do? Well, this is where you can add a decimal, add that decimal in, let it float up and sit there on the quotient bar, and then you bring down a 0. You can do this an infinite number of times, as many times as you need to in order to keep working with this number. For the last one, we have 186.3 divided by 27. So the 27 is trying to fit into 1. It doesn't work. That's what that X is. Okay, you're welcome to leave that blank or put in an X as a placeholder. Does 27 fit into 18? No, it does not. How about 186? Yes, it does. 27 fits into 186 6 times. 27 times 6 is 162. Now we're going to subtract. 6 minus 2 is 4. 8 minus 6 is 2. Bring down the 3. 27 fits into 243 9 even times because 27 times 9 is 243, and 243 minus 243 is a nice happy 0, no remainder. Okay, so we'll take a look at more of these on the back. Thank you for taking such great notes. See ya.